Okay, guys, in this video, we are going to review contingency tables. All right, so the first step is to find the row totals and column totals, which is not hard. You just add up the numbers. So let's do that. Should be pretty straightforward. Now, I always recommend making sure that the sum of the row totals, so these numbers, would be equal to the grand total, and also these two should also be equal to the same sum. So 90 plus 360, that is also for 450, so we got that part correct. Okay, now I will start actually recording what I am going to find because I'm going to need some of these answers later on. So first I am going to find the chance that somebody does not own a laptop. So this is a regular probability, meaning it's not conditional. So if it's a regular probability, you're dividing by the grand total. So the grand total here is 450. So you're taking the total number of people who do not own a laptop, which is going to be 100, and dividing that by 450. Okay, now it says 4 decimal places, but later on we're going to need this answer as a fraction. So I'm not going to delete it. I'm just going to enter the answer as a decimal for now. Next question says, what is the probability that the student prefers TI-84? So let's add a note. So TI-84, which would be the total number of people who prefer TI-84 divided by the grand total. So that would be 90 divided by 450. Okay, so that in decimals is just 0.2. Now, the next question is going to be kind of hard, I think, because every time people get to this and, like, does not own a laptop and prefers TI-84. So does not own a laptop and prefers TI-84. So this and, a lot of times people are confused what that means. So think of and maybe even write on your note card, both at the same time. So you're looking for how many people do not own a laptop and at the same time prefer TI-84. So that would be 20 people over here, right? So that will be 20, which is the overlap, divided by the grand total. Okay, so again, what do? You look at the table, right? You first look at whatever part does not own a laptop. So that would be a row. So highlight that. Then take the part that prefers TI-84, which would be this one. And the overlap would be this number, and then you're dividing that by the total. So that would be the 20 over 450. Okay, so I'm going to come back to these three because I might need them later on. Okay, so now part E is just a general additive rule. All you're doing is finding the OR probability, so you can see the ORs here. And you do not need to write down this additive rule on your note card because it's going to be available on the test. So you are just adding answers to part B and C. And let's do that. And we are going to subtract the answer to part D. So we're subtracting the overlap because we do not want to double count. So that would be my answer. Now, starting with part F and below that, you're going to need answers as fractions. Notice that in part F and G, you do not need to reduce them, but I think I'm going to do that anyway. But here, I have to. So just to be safe, I'll probably reduce them. Now, this part F is conditional probability. So how do I know it's conditional probability? So search for the word given, or sometimes they use the word if. So either given or if indicates that that is conditional. And then whatever follows after that word will be your condition, and that should be on the bottom. So what you're thinking about, I know that the student does not own a laptop. So now I am in the universe of students that don't own a laptop. How many of them prefer TI-84? So let's look at the table again. So again, I know that I don't own a laptop, which means that I am in this group right here. I do not know about anybody else. This is given. How many of these people prefer TI-84? Well, it would be these, 20. But this time I'm not dividing by the grand total because this is conditional. You are dividing by the total in the condition. So that would be 20 divided by 100. And let's see if we can also reduce that. So to reduce, you got the little button right here, right? That's the reduce. And that would be 1 over 5. Okay, so this is going to be 1 out of 5. All right, the next question is also conditional. And again, how do I know that? Well, because I see the word given. So it says, given that the student prefers TI-84. So now I am in the universe of people who prefer TI-84. So again, let's go back to the table. Let's highlight the condition when the condition was prefer TI-84. So this is my condition. How many of these people do not own a laptop? Well, that would be 20. But this time you are dividing by the total in the condition because this is conditional because you are in the universe of only people who prefer TI-84. So this would be 20 divided by 90, which is going to be just 2 over 9 if you convert that to a reduced fraction. Finally, let's see if we can figure out if these two events are independent. So A is a student does not own a laptop, and B is a student prefers TI-84. Now, I actually already know probabilities of these A and B because I have them right here. Okay, so that's available. Also, I found the chance that it's both at the same time, which is going to be what this first one is. So really your answer to part D, which is where you will find in the end, is really the same thing as this one, but this one you just have to enter it as a fraction, not as a decimal. So that's why I did not want to get rid of this, because now I'm just going to click on the little button, and that converts it to a fraction. So 2 over 45, okay? Now, how about this one? Well, this one you have to find probability of A multiplied by probability of B. But again, I already found them here. I just need to multiply these two, okay, and then reduce them. So I'll just hit enter on my keyboard. That is going to insert an empty line in the calculator, and I'm going to take these two numbers and I'm going to multiply them, okay? And now I'm going to convert them to a fraction, okay? So that is also 2 over 45. So that tells me that these two, this is called test for independence. Again, you do not need to write it on the card because it's going to be there. Because these two are the same, so they're equal, the events A and B are independent. Now, if they were not equal, obviously that would be not independent. And it's important to reduce the fractions, otherwise you might not see that they're the same. Because, you know, you can sometimes when you don't reduce it, the two fractions may seem like they're different, when in reality they're going to be the same exact thing.